Hello, and welcome to my video introducing mesh, sometimes called loop analysis. Let me start out by saying that you must learn fundamental concepts to solve electrical engineering circuit problems. Absolutely do not try to solve quiz and exam problems by trying to associate them with problems you recognize from the lecture or homework, because that's not the way it works. Lecture and homework problems are intended to help you learn and understand basic engineering principles that will give you the ability to work towards the solution of any problem in a logical, organized manner. The tools of the trade for the electrical engineer when doing circuit problems are these bulleted items here. And what I'm going to zero in on this video is using Kirchhoff's voltage law to analyze circuits with mesh analysis by assigning loop currents. So that's the intended. I have other videos to talk about nodal analysis and Thevenin's theorem and source transformations and things like that. But we're going to start by looking at the procedure that I have to analyze a circuit using mesh or loop analysis. Mesh analysis is a technique used to solve a particular type of circuit problem. Note, mesh or loop analysis uses Kirchhoff's voltage law to calculate loop currents. You do not need to label a ground reference when using this loop mesh analysis step, because you're not finding node voltages with this technique. You're finding loop currents. The procedure is a pretty simple four-step procedure that I'll let you look over. I'll let you go back in the video and check it out. But we're going to do this 2 or 3 times. You catch on to this real quick. But is the procedure that you should really memorize as soon as possible. Current sources in mesh and loop analysis present the opportunity to assign loop currents by inspection, making the analysis easier. And I'm going to show one of those examples here. And then current sources also open the possibility to create a super mesh, making the analysis easier. I don't have time for super mesh in this video, but I'll do it I have done it, and it's in other videos. So let's work out a couple problems here. And we're going to start out by looking at problem number 3. It looks like this. And we'll set up the equations. Problem number 3, there's our circuit. We want to apply mesh analysis to find the current I. So we want to find the current I in that circuit through the 1 ohm resistor. I want you to completely forget about that right now. We'll do that at the end. We'll find, just ignore where I is in that circuit right now when we go through this. So I already made the direction of the currents here, and I went clockwise. Notice where I1 is in the top window, I2 is the bottom left window, and I3 is the right bottom window. You could put I1 in the bottom left, and I2 in the bottom right, and I3 at the top. It doesn't make any difference, but this is the way I did my loop currents. I want you to always assign loop currents clockwise, because my procedure works perfect for that. You can assign the loop currents counterclockwise, and you're just going to get the negative circuit equation. You won't lose any intelligence in that equation with regard to the system or the circuit. But always select it in a clockwise direction. It makes everything pretty easy. So I want to go around loop 1. So I want you to concentrate only in this loop here. I'll draw a real big loop. That loop right there, which is your current I1. That's all I want to concentrate on. And I'm going to have you write by Kirchhoff's voltage law around loop 1. I want you to start at the bottom left corner of each window and just go around the loop, go around the mesh. Every time you see a resistor, it's going to introduce a voltage drop with a clockwise current. And since you're assigning your currents clockwise, like I told you to do on every one of these loops, As soon as you see a resistor, you say -10, and you stop and think. That's a resistance. What's the current through that resistor? It's simply I1. You follow around. What's next? You see that's 6 volts. You're going from a negative to a plus. You're going from a negative to a positive. You're going uphill. You're going in a more positive direction. So you're increasing the voltage. So that's going to be shown as a +6. Then you have a resistor, 2-ohm resistor. You say -2. Right away you say that, and you stop and think. You even pause. If you're in my class, I have you pause. -2, as soon as you see a resistor, negative the resistance value. And then you say, what current goes through that 2-ohm resistor? Well, there's 2 currents. There's I1 and I2. But since you're in loop 1, the lead current is I1 minus I2 equals 0. That's the top level equation. -10I1 plus 6 minus 2 times the quantity, I1 minus I2 equals 0. You clean that up a little bit and you get your first circuit equation. -12 I1 plus 2I2 plus 0 I3, because it's not represented. You're going to see why I'll get it in a standard form like that. You get it in a standard form to get ready to solve these with matrices or with an app on your phone or with your calculator. Don't try to do this with substitution like you did in high school. You just don't have time in these classes at the college level to try to solve these using algebraic techniques. So that's equal to a -6. I'm sorry. This turns out to be equal to a -6 when you work that out. So there's our first equation. That's equation number 1. There's one linear equation with 3 unknowns. So you know you have to come up with 2 other equations. So now you go by Kirchhoff's voltage law around loop 2. And just concentrate on loop 2. I'm going to start down here. I'm going to go around. I'll draw it nice and big here. There's I2. I start at the bottom left corner. You just start at the bottom left corner. And you see a resistor. You go around clockwise. A resistor. You say -4 right away. What current? I2. Then you see a 2-ohm resistor. -2. And you stop and think. What current? 2 currents. But the lead current is I2 minus I1. It goes in the opposite direction. You always subtract the other current when you always do it in a clockwise direction. That's the beauty of this procedure. Then you have a 1-ohm resistor, -1. Then you stop and think, what current? I2 minus I3. -8. Take a look at that. You're going from positive to negative. You're going from a positive to a negative, more negative voltage. So that's a -8. And that's going to equal 0. There's your second equation. You clean that up, and you end up with a +2I1 -7I2 +1I3 equal 8. Now, you may get the negative of these equations. It depends what you take to what side, the left and the right. You could have got a 2I1 plus 7I2 minus 1I3 equal -8. It's the same information in that equation. It's just like multiplying through by a -1. So there's equation number 2, using mesh analysis. Then you go around loop number 3, and you say by Kirchhoff's voltage law around loop number 3, and you start the bottom left corner, and let's go around that loop. Let's go around that window. Very easy. Start the bottom left corner. +8. Resistor, -1. What's the current? I2 minus I3 minus I2, because you're in loop 3. -6. Because you're going downhill. That's 6 volts. You're going from plus to minus. -6. minus 5, you stop and think, what current? Just I3 equals 0. Clean that up. You get a plus 0 I1 because it's not represented. Get it in a standard form. Plus 1 I2 minus 6 I3 equal negative 2. That's equation number 3. 3 equations, 3 unknowns. And you solve those simultaneously using your calculator or matrices or whatever. And what we end up with here is we end up with x1 is equal to 0.329 amperes. I2 is equal to negative 1.026 amperes. And I3 is equal to 0.162 amperes. Now, when you get your loop currents, now you go back and look at what they want you to find in the circuit. That's when I is introduced. And let the math do the work for you. Don't say, well, wait a minute, I1 goes in the right direction clockwise because it's a positive. This is a positive value, so it was the right direction. I2 is a negative value, so it really goes in a counterclockwise direction. I mean, yeah, don't try to clutter your mind with that. Just look at the circuit and say to yourself, what is I in that circuit? I goes in the same direction as I3, the way we assigned it. So it has to be I3 minus I2. Or in our case, I is equal to I3. Oops, there's small letter here, usually reserved for time sensitive, but I'm not going to worry about that. I is equal to I3 minus I2. It's just a plug-in. Just plug these in here. And let the math do the work for you. So you're going to see that I is equal to 1.188 amperes. And that's the answer to that problem. Let's do some mesh analysis. Let's do another one. Let's do problem here that I have picked out. I picked out this problem here. A little simpler, 2 by 2. For the following circuit, find the currents IA, IB, and IC. So for now, let's forget about that. Let's forget about that. Let's do the loop currents. There's I1. And here's loop current I2. Okay. And I'm just going to do my mesh analysis here. I'm going to say around loop 1 by Kirchhoff's voltage law. And start the bottom left corner and go around that loop. Go around that left window. And what you should see is a plus 30, minus 20, because it's a resistor. Think what current, just I1. Minus 10, open parentheses, stop and think, what's the currents? Well, you have the I1 minus I2 in this case. You're always going to subtract the other current the way I do this. Plus 45 equals 0. You clean that up and you get yourself your first equation out of 2. You get minus 30 I1 plus 10 I2 is equal to a negative 75. That's equation number 1. Then you go around loop 2. By Kirchhoff's voltage law again. Start the bottom left corner down here. Go around that right window. See if you get this. A negative 45. I'd stop the video and then see if you get what I get. Negative 45 minus 10 times I2 minus I1 minus 5 I2 minus 15 I2. equal to 0. You get a minus 45, minus 10 I2 minus I1, minus 5 I2, minus 15 I2 equals 0. Clean that up. I get a plus 10 I1, minus 30 I2 equal 45. That's equation 2. You solve those simultaneously. Again, I wouldn't use substitution. I would use an application to solve those, or do with determinants, plug it into coefficients and the constants. But you end up with I1, that loop current is equal to 2.25 amperes. So it was assumed in the right direction clockwise. I2 is equal to a negative 0.75 amperes, which meant it really goes in a counterclockwise direction. There's your I1 and I2s. Now you can get the IA, IB, and the IC involved here. So if you take a look and just let the math do the work, don't try to analyze everything in your head. IA, if you take a look here, what IA is equal to, IA is equal to, take a look at that circuit. Take a look at the circuit. Do you see that it's simply equal to a negative I1? It goes in the opposite direction of I1. So if it's equal to a negative I1, you end up with negative 2.25 amps. IB, just take a look at the circuit. Do you see IB is equal to I1, because it goes in the same direction as I1, minus I2? Just plug it in. Plug in the I1s and the I2s there. You get your 3 amps. Positive 3 amps. We'll write it in. Plus 3 amps. And what's your IC looking at that? Well, IC is simply I2, which is equal to a negative 0.75 amperes. And there's your answer to that problem. IA is a negative 2.25 amps. IB is equal to 3 amps. And IC is simply equal to negative 0.75 amps. Now, how does this simplify real quick if you have current sources? Because I said I would do that in this. So let me throw that in here real quick and show you how incredibly easy it makes it when you have current sources like this. For the following circuit, use mesh analysis. Take a look at that circuit. We're going to use mesh analysis now. So you can assign the loops, I1, I2, and I3, wherever. I'm going to do I1 up here. There's I1. I'm going to do I2 down here. And I'm going to do I3 over here. That's how I'm going to establish my mesh currents. Then I'm going to look at that circuit. And I notice I have a current source right there. And since I only have one current flowing through that current source, I can look at that and say, well, by inspection, that means just by looking at the circuit, by inspection, I can see that I3 is equal to a negative 3 amps. I'm 1/3 done already. I'm 1/3. It goes in the opposite direction the way I signed I3. It's the only current gone through it. Now, when you have two currents going through a current source, two loop currents going through a common current source, like you would have like this, look. There you have that, and then you have a loop over here, and you have a loop over here. Let's say you signed that as I1, and you signed this as I2, and there, this was 3 amps right there, we'll say. Well, that shares those. That's called a super mesh. That's called a super mesh. Oh, they're real easy to handle, super meshes. I have a video on that, a separate video on a super mesh. But we don't have that situation here. So I can see I3 is equal to a minus 3 amps. So right away, I want you to look at that and get that in a standard form. You know you're going to have an I1, I2, and an I3. So I'd get a standard form out of that. I'd say 0 I1 plus 0 I1 plus 0 I2 plus 1 I3 equal 3. There's my first equation, and it's in a standard form, see? Now I do by Kirchhoff's voltage law, I'll do it this way, around loop 2. Just look around loop 2, starting at the bottom left corner. See if you end up with this. You end up with a plus 12, minus 4, times I2 minus I1, minus 3, open parentheses, don't forget that, I2 minus I3. You start out with I2 because you're in loop 2. You're in loop 2, so you start out with that. Yeah, equals 0. Then you clean that up, and you get your second equation. I end up with a 4I1 minus 7 I2 plus 3 I3 equal a negative 12, or the negative of that equation. Same information. There's equation 2. And then you say by Kirchhoff's voltage law around, and we'll do loop 1 now. We could have done this first, but we'll go around loop 1 now. We'll do that. Doesn't make any difference what order you did do this. So I'm just going to go around loop 1, starting at the bottom left corner, go around loop 1. And see if you get the same thing I get here. I get a negative 24 minus 8I1 minus 4 I1 minus I3 minus 4 I1 minus I2 equals 0. I clean that up, and I get a negative 16 I1 plus 4 I2 plus 4 I3 equal 24, or the negative of it, for my third equation. I get 3 equations and 3 unknowns, and I solve that for I1, which is equal to negative 2.5 amps. I2 is equal to a negative 1 amp. I3 is equal to a negative 3 amps. Now I go back and I look at how I is defined. I take this information here and I go back and say they want I in this problem. Let the math do the work. Is I1 equal to I3 minus I2? Is I equal to I3 minus I2, or is I equal to I2 minus I3? Think of that. Well, it goes in the same direction as I2, so I has to equal I2 minus I3. And if you let the math do the work, you're going to get I is equal to a negative 1 minus a minus 3. You're going to get I is equal to 2 amperes. And that is the answer to this problem. And I hope that helps you with understanding mesh analysis. Be sure to check out my video on nodal analysis as well.